So today we will talk about solubility and solubility products, right? So basically there are certain salts which are very soluble. So they are known as high soluble salts. High soluble salts. For example, it includes all the nitrates, and it will include all the salts of like sodium, potassium, sodium, potassium, and cesium, rubidium, of ammonium. So it includes all the salts of these. Right? These are very high soluble. Next, we have another category of salts which are known as sparingly soluble salts. Sparingly soluble salts, right? Basically it includes all the salts of like phosphate, the salts of like, for example, we have AgCl, we have barium sulfate, we have silver chloride, we have silver iodide, right? And we have, for example, we have AgBr. Right? These all salts are basically insoluble, right? Basically in organic chemistry, in physical chemistry, these salts are known as sparingly soluble salts, but in inorganic chemistry they are known as insoluble salts. Insoluble salts, right? Consider that let us dissolve one salt. Okay, here consider that we have a salt which is known as AB, and it is in salt form, and it had dissolved in water, and now it will form its ion. So it will be A positive and B negative. So let's write a constant for this, which will be A, here B, divided by A B. This is in gaseous, this is in gaseous. Okay, we have read a rule. In my previous video I have taught you guys that when there is a solid and a gas, then the concentration of solid is constant, right? So this is here the constant. It will not change. So it will go there and get multiplied and will form K A B is equal to A multiplied by B. Right, these both are now constants, so they will multiply and they will form another constant known as KSP, solubility constant of solubility product, and it will be equal to concentration of A upon concentration of B. Right, this is KSP. We can also write this as KSP is equal to QSP. Now what is QSP? QSP basically is the ionic concentration, or you can say it is the product of molar concentration of ions. Product of molar concentration of ions, that is known as QSP basically, right? So basically there are certain ways in order to find the QSP and KSP, and like there are certain applications. Let us discuss about the application of this KSP as well. Okay, it basically depends upon the solution and the type of solution and the precipitation, right? If we talk about the type of solution, number first is saturated solution. Okay, one thing to remember is that this condition KSP is equal to QSP will always be in the saturated it will be always in saturated solution, right? Okay, if it is a saturated solution, then the KSP will be equal to QSP, and there will be no formation of precipitation. No formation of precipitation. Now second is unsaturated solution. Right, in this basically KSP is greater than the QSP, because as you know that unsaturated solution, the maximum amount of solute is already not present. So how the QSP, how the ionic concentration will be greater? So obviously KSP will be greater than QSP, and it is no precipitation, no PPT, right? Basically, precipitation is a double displacement reaction in which the one product is formed, there is a mixture of two reactants, and the product, one product is soluble and the product is insoluble, right? We have another kind of reaction which is basically super saturated solution. Basically, in this, KSP is smaller than the QSP, and there will be formation of PPT. PPT will be formed, like precipitation will be there. There will be precipitation. So if we talk about the insoluble salts, like these sparingly soluble salts, they are quite important for us in industry, in medicine. Like we have a salt known as barium sulfate. Barium sulfate. Basically, this salt is used to diagnose ulcer in food canal, right? It is used to detect, barium sulfate is used to detect basically ulcer in the food canal. Basically, ulcer is caused by Helicobacter pylori bacterium. So yes, so I hope this is clear to you. If you have any kind of questions, you can ask